Assalamualaikum and good afternoon everyone. My name is Ifal and today I'll be telling you about mathematical terminology and one of the methods that can be used. Proof is a mathematical statement as an expression which is either true or false. Mathematical proof consists of an axiom derived from previous statement and a previously derived statement. Next, we have the hierarchy of terminology which consists of proposition, theorem, lemma, and corollary. Firstly, proposition is a true statement of interest that you are trying to prove. Secondly, theorem is a proposition that I consider to be extremely important. Thirdly, lemma is a preliminary proposition that is used in the proof of the theorem. And lastly, corollary is a true statement that is a simple deduction from a theorem or proposition. We will now move on to the construction method, but first we will connect you guys to one of our friends out here to talk about it.
Hi everyone, my name is Daniel and today I will talk about construction method. So, what is construction method? Construction method is a mathematical proving that is used when there exists the quantifiers, which is there is. When can we use it? We can use this method when the conclusion B is there is an object with a certain property such that something happens. So, what are the steps of construction method? Step 1, you have to identify every object and certain property and something happened. Construct the object by using hypothesis guess. Procedure, devise an algorithm of procedure. In example, if P and Q are even integers, then 3P squared plus PQ is divisible by 2 or 2 divisible by 3P squared plus PQ. So here is the analysis of proof. And this is the condensed proof.
Alright, thank you Daniel. Now I think we need another example for this. If all of you guys that are watching this have another example, you can call this number on the screen and we'll reach you out to give an example. We will be right back after the break. Well, we are back for another 2 examples for construction method. So, we have a caller from Tapa wanted to give us another example for it. His name is Zikri Haris. Hello Zikri, how are you? Can you give us another example for the construction method?
And now we move to the example. If A, B, C, D, E and F are real numbers such that AD minus BC not equal to 0, then two equations AX plus BY equal to E and CX plus DY equal to F can be solved for X and Y. So, from the statement, we can identify our A is A, B, C, D, E and F are real numbers such that AD minus BC not equal to 0. And B is two equation AX plus BY equals to E and CX plus DY equals to F can be solved for X and Y. And we can identify that there exists real number X and Y such that AX plus BY equals to E and CX plus DY equal to F. So after that we can identify our object, certain property and something happen. For the object are real numbers X and Y, and for the certain property it doesn't have certain property, and for the something happen AX plus BY equals to E and CX plus DY equal to F. So we start with our first equation is AX plus BY equals to E and the second equation is CX plus DY equals to F. So from the first equation we times with D and we get the third equation, and for the second equation we times with B and we get our fourth equation, and from equation 3 minus equation 4 and we get our X equals to AD minus BF over AD minus BC. After we get the X, we substitute the X into our first equation and we can solve it and until we get Y equals to AF plus CE over AD minus BC. After we get x and y, we can write A1 x equal to ED minus BF over AD minus BC, and y equals to AF minus CE over AD minus BC, because AD minus BC not equal to 0. And we also can get B1 equals to AX plus BY equals to E, and CX plus DY equals to F. So we move to the A2 is AX plus BY, and we substitute x and y into the equation, and the final answer we will get, the answer is E. And we move to the A3. Also we substitute x and y into the equation, and we got the final answer is ADF minus CBF over AD minus BC equals to F. And we move to the A4. AX plus BY equals to E, and CX plus DY equals to F. And our A4 we refer to B1, and is exactly the same thing. And for B, there is a real number x and y such that AX plus BY equals to E, and CX plus DY equals to F. And we move to the condensed proof. On multiplying the equation AX plus BY equals to E by D, and the equation CX plus DY equals to F by D, and subtracting the two new quantifiers, one obtains AD minus BC at X equals to ED minus BF. From the hypothesis, AD minus BC not equal to 0, therefore by dividing with AD minus BC, X equals to ED minus BF over AD minus BC. Similarly, with y equals to AF minus CE over AD minus BE. It can easily be checked that for this value of x and y, AX plus BY equals to E, and CX plus DY equals to F.
Alright, thank you Zikri for the great example. Next, we have another caller from Tuli Intan that want to give us another example for this. Hello Omar, how are you today? Can you explain to us more about the example that you want to give us today?
Thank you, Ifa. Now, let's move to the example of construction method. Let's take a look at proposition. If m less than n are consecutive integers and m is odd, then k is an even number such that k equal to m square plus n square minus 1 for all positive integers of k. We move to proof analysis for construction method. The goal is to show that we can construct k in a way that it is explicitly an even number. For example, k equal to 2y for some integer y. Step 1. Work forward from A. A1, m and n are consecutive integers, so we can write n equal to m plus 1. A2, m is an odd integer, so we can write m equal to 2p plus 1 for some integer p. A3, substitute n into the equation for k. K equal to m square plus n square minus 1 equal to m square plus m plus 1 bracket square minus 1. Step 2. Work backward from B. B1, we want to show k is even, so we need to construct k in the form k equals to 2y for some integer y. Step 3. Link A to B, the construction. Continue working forward from A3 to manipulate the expression for k, which is k equals to m square plus bracket m square plus 2m plus 1 minus 1. K equals to 2m square plus 2m. K equals to 2m bracket m plus 1. At this point, we have successfully constructed k as 2 times the integer, which is m bracket m plus 1. This satisfies the form k equals to 2y, where y equals to m bracket m plus 1. To be more explicit, substitute A2 into this result, which is k equals to 2 in bracket 2p plus 1 times 2p plus 1 plus 1. K equals to 2 bracket 2p plus 1 bracket 2p plus 2. K equals to 2 in bracket 4p square plus 6p plus 2. And then K equals to 2 in bracket 2p square plus 3p plus 1. Lastly, for conclusion, we have construct K such that K equals to 2y, where y equals to 2p square plus 3p plus 1. Since p is an integer, y is also an integer. Therefore, by definition, K is even. The proposition is proven by constructing the required form. Okay, that's it from me. Thank you.
Alright, thank you Umar for the example. I think we are almost at the end of the talk here. I would like to give special thanks to all of the listeners and people who are helping us making this talk possible. Thank you everyone and see you later.